Hello everyone, welcome to Virtual School Physics is Fun. This is Puan Liao speaking again. Okay, today our topic is force. What is force? Force is a push or a pull. Okay, for example, this guy is pushing with 10 Newton, whereas this guy is pulling with 10 Newton. So a force is a push or a pull. So it has got magnitude, both of these guys pushing and pulling with the same magnitude but different direction. Okay, different direction. Therefore, force has magnitude and direction, and it is a vector quantity. Now, force is measured using spring balance. Okay, spring balance, and the unit used, the SI unit is Newton, or it can be stated as kilogram meter per second square. What is the effect of force? What can force do? Force can change the shape of an object, the size of an object, or even the direction of an object. Yeah, direction of a moving object. Okay, if a force is applied, you see that the speed of an object also change. Okay, so the state of motion of an object changes too. All right, so this is a summary of the effect of force. So force can change the shape, the size, the direction, the speed, and state of motion of an object. When the force is applied onto an object, the object which is not moving initially will start to move. Okay, therefore it accelerates. When it starts to move from stationary, so it accelerates. What's the relationship between force, mass, and acceleration? All right, now if we have a greater force, right, for example, this son is pushing the trolley as compared to the father who is bigger and have got more force pushing the same trolley. So obviously with the larger force, will the father be able to push the trolley with the higher acceleration? Of course, logically it will tell us that when force increases, the acceleration increases. Okay, what about mass? Now, if the same force is applied, the same person is pushing the trolley, but now the mass is higher, the mass is greater. So what will happen to the acceleration? Common sense will also tell us that when force applied is the same, when the mass increases, the acceleration will be lower. Okay, right? When mass increases, acceleration decreases. All right, these are the experiments that we can do to find out the relationship. Yeah, so I will skip all those. Now, relationship between force, mass, and acceleration. So from the experiment, we can conclude that when force increases, acceleration increases. And not only that, their relationship is actually directly proportional. Whereas mass and acceleration, if we increase mass, acceleration decreases. Just now we have seen, we say logically, every one of us will know. But how is the exact relationship? So if we carry out experiment, we will find out, we will be able to draw this graph. And this graph means inversely proportional, right? So meaning to say, mass is inversely proportional to acceleration, whereas force is directly proportional to acceleration. Okay, so I write it in symbol form. So acceleration is directly proportional to force. Acceleration is inversely proportional to mass. So from these two relationship, these two conclusion, we sum up. Yeah, we make a final conclusion, that is acceleration is directly proportional to force but inversely proportional to mass. Okay, so acceleration of an object is directly proportional to the force that is applied on it, but inversely proportional to its mass. So from this relationship, we change it to an equation, right? We are able to change it to an equation, and we see that F is equals to ma. Force is equals to mass times acceleration. All right. So this formula is found out by our physics, the father of modern physics, that is Newton. Okay, Newton stated this in his second law. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it, but inversely proportional to its mass. Okay, so this famous formula F equals to ma, right? It is very important to physics students. So please remember this formula well. So with this formula, we are able to do a lot of calculations, okay, using this formula. So do try some or try to use this formula to solve problems. Okay, all right. There are many examples that you can get from your book or online. Okay, I will not go into the examples because of time constraint. Yeah, so you try it out. All right. So I will continue with other topics on force. So do watch out for more videos. Bye. Thank you.